Hedges. I'm your host, David Mansouri, and today we're talking about innovations in health with Dr. Sabia Abidi. Dr. Abidi is a bioengineering educator with expertise in stem cell research, microfluidics, and disease treatment. She teaches bioengineering fundamentals, quantitative physiology, and global health at Rice. Prior to Rice, she conducted research at MIT, focusing on sickle cell disease and red blood cell treatments. Dr. Abidi earned her PhD in biomedical engineering from the University of Texas at Austin, where she explored cell production techniques for immune-related diseases. She's passionate about mentorship and STEM outreach, actively engaging in programs that support students and young engineers. Dr. Abidi, thank you so much for the time today. Really looking forward to our conversation.
I'm honored to be here.
So maybe just to start off, you are a bioengineering educator. You have expertise in stem cell research, microfluidics, disease treatment. And I want to ask maybe a very basic question, which is, can you tell me what exactly is bioengineering and maybe what got you into this field in the first place?
Yeah, I would love to. So I think a lot of people confuse biological versus bioengineering, or sometimes as it's referred to as biomedical engineering. And I think, to be clear, bioengineering or biomedical engineering is really the application of engineering to medicine. So really improving health outcomes, improving people's lives, disease states, chronic conditions. And biological engineering gets more into think about animals, think about I don't know, sometimes food production. So it's not necessarily medicine or clinical states. So that's how I would separate the two. And I'll say that folks will call it bioengineering. Folks will call it biomedical engineering. It's the same thing. Sometimes people say, well, what's the difference? I think it depends on the program and what the strengths are in terms of that university. I can tell you in high school, I was one of those that was good at math and science. And I remember getting interested in how cells were talking to each other. And that seemed to be the thing that really got me hooked. I was in a library and I was reading some sort of a paper on receptors and ligands and how cells are telling each other what to do. And I just thought, wow, this is really cool to be in this space. At the time, tissue engineering was also taking off. And for those that are not familiar with tissue engineering, this is generating human tissue outside of the body for diseases and chronic conditions. So you can think about burn victims, for example. They don't have maybe available skin for various parts of their body. So this would be an alternative to the human skin that they can maybe go and implant on an area, and then the people are fine. So that whole world was taking off at the time. I'm dating myself now, but taking off at the time that I was in high school. And I was fascinated. Stem cells were also becoming like a major thing. People were talking about them. And there was this one image of a mouse with a human ear on it that was super popular. Or like media got sight of it, and it was all over the place. And I was like, this is what I want to do. So that was in high school, and I've been in bioengineering since then. I've been in global health a little bit here and there, but bioengineering has been the common thread.
Great. Thanks for sharing that. So in your field right now, what are some of the things that, I don't know, maybe that are top of mind for you, or that you're thinking about, or maybe even that you're most excited about in the research that you're doing, or even just things that you're watching closely in the broader field?
Yeah, so to be clear, I teach full time now. I did a lot of research throughout my education, and I completed, like you said, I did my PhD, and then I did a couple of postdocs. And so the research has always been there, but now I have the luxury of working with students full time. That being said, I have a program that I do work with the Medical Humanities where students are actually in the hospitals finding ideas for design projects. And so that is maybe a space for students to continuously innovate and create solutions. In terms of what I'm thinking about, what I'm excited about, I am very intrigued with this whole world of AI and customizing solutions, tracking data, and finding solutions to problems in creative ways. I feel like this world of uh, data collection, customized medicine is really exciting for all of us because our bodies are so unique, our physiologies are so unique, and there's no one size fits all. And so if you have the ability to really customize that treatment, and provide something that's appropriate for you and maybe not somebody else, and also detect things earlier, from things like smartwatches or other wearables. I find that very, very exciting. I will say that I'm a little bit removed from the stem cell tissue engineering space, but whenever I do hear of what's going on in that field, that's also interesting as well.
So I want to talk a little bit more about the work you're doing with students and the Med Center and creating those kinds of opportunities. But maybe one last question to go a little bit deeper on bioengineering more broadly, and it's actually just to ask you to talk a little bit more about the intersection of bioengineering and artificial intelligence. This is obviously something that people are thinking about in every field and discipline, right? How does artificial intelligence intersect with work? And just wonder if you could talk a little bit more about what are some of the, I don't know, use cases perhaps of how artificial intelligence is changing the field, or helping to accelerate work that's happening in the field, or creating new ways to think about the work.
Yeah, and I'll preface everything by saying that I am not working in the artificial intelligence space, and so I will try to speak as accurately as possible. I'll tell you where I see this most is in the way design projects are presented to me, and so the way these projects are a lot of times presented and offered, and the way they can actually make an impact is, if you think about it, we've had these sensors all along, right? Or, a lot of these sensors have existed. So ways of measuring, I don't know, how many steps you're taking, what your heart rate is, right? But now what they're doing with things like AI is they're taking that data and then predicting what's going to happen, right? So using the models or using the data that they've collected, now they can say, well, maybe using this input and that input, this is the condition that you have. This is what you should actually take. This treatment is appropriate or is not appropriate. So that intelligent algorithm, which is what this artificial intelligence is really doing, based on data that they've collected from you, and kind of predicting and speculating what's going to happen in the future, is very powerful. And you're seeing that all over the place. An example that I know is really taken off is a lot of imaging data. So you can feed imaging data into these AI algorithms and figure out, oh, this person has this, or there's this kind of a problem. Whereas and you're saving human time. Sometimes these algorithms are picking up things that are very difficult for humans to pick up. I think the thing to keep in mind, though, with these algorithms, with AI, are the biases that are present, right? So these algorithms are only as smart as the data that you feed them. So if you feed them bad data, they're going to give you a bad result. So that's kind of where I'm also interested in terms of like bias and making sure that we're being as accurate as possible in terms of training these algorithms.
Cool. All right, let's talk about teaching, which I know is the major focus of your work right now. And you talked a little bit about the experiences that you're creating for students, and want to ask you to share more about the Medical Humanities Research Institute, which is a clinical immersion program for undergraduate bioengineering students. Tell us about that program, and also what benefits you feel like it's providing to undergraduate students.
Yeah, so this is a new program. I know that the institute, before it was an institute, it was certainly a minor, and I saw it. So before it was an institute, I saw it in the way where our bioengineering students were taking this minor. They had this minor, and I was also very curious about what these courses were like. But what I think the power of medical humanities is approaching problems from a perspective that we're not necessarily trained in. As bioengineers, we look at things in terms of, I don't know, here's the biology side, here's the engineering approach, here are the equations. And with medical humanities, you're really thinking about the experience. You're thinking about these people, where they're coming from, really getting into that human-centered design aspect. And so that's the power of combining with medical humanities, for example, with this grant that we have together, where students, these bioengineers, they actually go into hospitals and they're looking for areas for innovation, and they're trained to look at these spaces in a certain way, but with tools from medical humanities, they can really dig into problems and understand, okay, what are the human related issues here, and are we solving the right problem?
Could you share maybe a example of what that actually looks like in practice? Like, what are students actually doing? What tools might they be using or sort of elevating?
Yeah, sure. I'd love to. So there's one tool, for example, that the students use in the program, and we brought it into Capstone because I consider it so powerful. It's called storyboarding. And so a lot of times people use storyboarding, when they're doing other things, and we don't necessarily consider the power of it. With something like storyboarding, students have the ability to take a situation and kind of deconstruct it in terms of how is time playing a role? How are people contributing to the problem? How is the space contributing to the problem? Looking at all the variables present. And then they think about, okay, well, this is happening because of this. And then long term, these results happen. And when we go through this iterative approach where we're like, okay, let's kind of dig into this part of it, it really helps them think about what are the real causes of this problem. And so in our program, we have them do these storyboard iterations over and over and over again. And it certainly helps them think about the problem in a more holistic way. It's not just caused by X, it has X, Y, and Z all contributing at the same time.
And maybe one other question on this program. So if I'm a bioengineering undergraduate student at Rice today, like, what does it literally look like? Am I going across the street to the med center to engage in a clinical experience? Like, what does that actually look like in terms of my sort of day-to-day experience in the program?
Yeah, so I would say, Rice Bioengineering is incredible in that majority of our students are actually doing research undergraduates are doing research during their time here. And that research could be in one of the fantastic labs we have on campus, not only in the bioengineering department or other departments as well. Our students speak a lot of languages, and so it's not uncommon for them to be in a non-bioengineering lab, but doing work that is sort of in that bioengineering space. I think that's the beauty of working in this discipline. But a lot of our students are actually across the street working in the medical center. And that is one of I would say that a huge strength at Rice University is that we are so close to the medical center, and you have people that are at top of the game in terms of physicians and treatments, and students get an opportunity to innovate in that space and do science in that space. So a lot of our students are across the street doing work there.
That's great. So another part I know of the work that you do with students is advising student groups on creating medical devices, which is something I was really interested in hearing more about, and wonder if you could talk about why that work's important to you, and maybe some examples of some of the most innovative projects you've seen so far from Rice students.
Yeah, I would love to. So I feel blessed that I teach capstone design. So this is a required 1 year class for our bioengineering students. Capstone design is also a required course for all the engineering programs at any university. What we do is we get these projects from industry, we get it from physicians, we get it from our own faculty. It's a 1 year long program, but it's all rooted in real problems, right? So it's the culmination of their entire education at Rice. And so they're applying a lot of these concepts they've been learning in the classes, and they're actually interacting with a client or with a sponsor and talking to them on a regular basis and saying, okay, look, this is our understanding of the problem. This is where we're at. What do you think? And they get facilities, amazing facilities at Rice, whether it's a design kitchen or a lot of our faculty come in and help them and advise them time to time. I have to say that I also went through a capstone experience in my undergrad, but it did not compare to what we have here at Rice in terms of the resources, the facilities, and these real life problems. In my experience, when I was a student, I had to find the problem, right? And I was proud of my experience. I'm happy with what I did. But these students, they're really working on these amazing problems that are presented to us. And our students do really, really well. We require them to submit to national competitions. They place every year. This is my sixth year, and every year they're second, first, third place in a variety of different national competitions. As it turns out, one of our teams last year won the first place award at a national NIBIB Venture Well debut competition. And they recently, this past weekend, they accepted the reward in Baltimore at the Biomedical Engineering Society meeting conference. And their project, just to give you a little bit of a primer, their project's on continuous bladder irrigation. So the way it's currently set up, practitioners or nurses or physicians that are taking care of these patients that have bladder issues, they have to go in and kind of just inspect the tubing and say, oh, it looks like there's this much blood, or the whatever the tube, there's just this color, and so we're going to kind of adjust the dose of irrigation to this amount. So it's a very subjective process, and they have to kind of go in and check continuously. And you can imagine that 3 a.m, nobody wants to be in there checking. And so they automated the whole system. And so they've automated the detection, and they made it a smart system that can actually control the flow rate and notify the practitioner. They can be somewhere else and they see what's going on with the patient. So the whole system is a very holistic system. It saves time, it helps the patient. And they started a startup, and so they're running with that as well. So they've done quite well. And that's just one example. I have brilliant students, and they do great work.
And these are undergraduate students who were working on this. Yeah. So I find it so interesting that a lot of the examples that we've talked about, you're working specifically with undergraduate students who are doing really amazing things. And I wonder if you could talk a little bit more about the undergraduate experience here. Why are you spending so much time with undergraduates? I think some of the examples that you've given, folks might think, well, there's things that graduate students might be working on. But I find it fascinating, amazing that all this work is work that you described as work that you're doing with undergraduates. Would love for you to talk about that. Why is that important to you? Is that unique to Rice? I'm just curious about your perspective on that.
Yeah, I think so. I'm trying to think, this is the fourth institution that I've been. So I've done postdocs at a couple places, and then, undergrad and PhD. What I find so special about Rice undergrad is the importance they put on their teaching. They take that very seriously. And you can see that in all the faculty that teach a class. They don't just put material in front of a student. They present ways of sort of interesting ways to engage with that material. And the quality of the students that we get at Rice, they don't just want the material. They want to see the applications. They want to see how it intersects with other fields. And I think Rice undergrad curriculum is unique, certainly in the bioengineering. That's probably what I know best. It's maybe just goes hand in hand with the field that we do that. We can do that. And so I think Rice undergraduate, the bioengineering program, is very special in that there's a lot of opportunities for students to interact with the material in different ways, depth and breadth, both.
One other question maybe about your work with undergraduate students. You, I believe, have 3 patent applications from your prior research, and I'm curious about how that experience informs the work you're doing with students who are working on medical devices and other work they're working on.
Yeah, so the patents, I was lucky to, whatever work I was doing at various times, whether it was undergrad or grad or my postdoc, I feel like I followed the work because it interested me, and I didn't necessarily go out to file a patent. I was lucky enough to be working in a space where there was not anything done. And so those were sort of a bonus and a plus. But what I do tell students in terms of our capstone program is we do ask them to investigate that space. And so, for example, if they're given a problem that is working on, I don't know, focused on artery, so artery disease, right? We do actually ask them to look at that patent space to see what's out there and to make sure that they're creating a solution that's different. Now, that being said, our primary goal is an educational goal, an academic goal. And so we want students to go out there and create a solution, but they're not necessarily responsible for the business side. All that being said, I mean, if we can get more startups from Rice Bioe, that would be amazing, right? And so it is certainly a part of the process, and we do ask them to investigate that space. So because we want them to create something that's innovative and different, but the business side of it, unfortunately, we just don't have the time to get into that a whole lot with the capstone experience.
Sure. So I want to talk a little bit about your role as a mentor. I know you do work with Big Brothers Big Sisters. You also mentor freshmen in engineering design. And I'm curious about why this mentorship role is so important to you. What drives your interest in mentorship as something that you're focused on?
Yeah, I feel like I've been very lucky to, I don't tend to look backward. I look forward. So I look at new projects and new ideas and where I want to grow. But when the times I do look backward, I guess those are times when I have to write a bio or something. But I do look backward and I'm like, I've been so lucky. I've had such amazing people in my life, whether they were faculty, whether they were teachers from high school, whether it was my parents, my husband, my family, whoever it was in whatever form they came. But I've had support all throughout. And I believe that, like, I see this in my students, they're all gifted. Without a doubt, they're all gifted. However, at times, I think they can maybe not see that. Sometimes they get in their own way. And it just helps to have another person looking at things from another perspective, maybe a zoomed out perspective, to bring things into the appropriate perspective. So you see things as you should. And so with Big Brother, Big Sister, I have a little sister who she's actually at Rice. And so, and she's incredible, just an incredible person. But I connected with this organization just because I think it's important for us as human beings to connect and give back. And I think especially if you've been lucky with various accolades or successes, that's the least we can do is to help others. And engineering, the freshman teams, that's also just a delight. It's just a thrill for me to do that. I'll tell you that it's a one semester. Um, uh, One semester commitment, not 1 year long, and it's not the actual, maybe, how do I say this? It's not like capstone. I feel like it's a little bit more intense. So this is just one semester, and the projects are super interesting. They're not always medical device related that I'm advising on, and these are freshman students, so it's like a different kind of energy. It's so heartwarming to see these students evolve even just over the course of a semester, if you think about where they started, where they ended up, and just put questions in front of them, ask them to think about things in different ways. It's just really rewarding for me. And I feel like every time I talk to these young students, I walk away with energy. I walk with kind of a new appreciation for what I'm doing. And sometimes it's a great pick me up at the end of the day. It also just makes me feel good.
Last question I'd have, and then we'll turn to a bit of a lightning round that we're asking in each of these interviews. You mentioned earlier the pivot you made really from research to teaching, and it's clear that you have a passion for mentorship and teaching at Rice. And I'd love for you to talk about that. Why did you make that pivot? What's been perhaps most rewarding about leaning in full time into the teaching space? I don't know. Is there anything you miss about doing research too?
Yeah, I feel like if you look at my history in terms of what all I've done, whether it's undergrad, grad, my postdocs, there was always a teaching component, right? So it's sometimes, we think we're headed in some direction, and then if we just kind of open our eyes and see, we'll be like, well, wait a minute, there's all these clues here. And so, I I mean, it probably started as early as even high school, or even before that. But I think all along the way, and if you're in academics, I think you feel like this, you're curious, right? You like learning, right? This is the environment in which you feel content and happy. You like people asking questions, and you like sort of digging into that. I think with research, that is exactly what you do, but you're doing experiments oftentimes, right? So you're working with cells, you're working with animals, you're answering deep scientific questions and working in a field that nobody knows the answers to, right? With research, I think it can be repetitive, but I tell students oftentimes there's no better thrill than having your paper published, right? And that world, the world of looking at data, of planning experiments, getting experiments to work, is intense, but can also be very thrilling. All that being said, I think what was missing from my research life was the human interaction. And it kind of goes back to my previous answer, but I think when you connect with humans on a regular basis and you listen, you hear what they're going through, and you try to improve, I don't know what, like their understanding, it's just a lot more rewarding. And those signs were there for me all throughout. It wasn't until I moved to Houston. So I'd finished my postdoc from MIT and I was in Houston, and I did it more on just a whim where I was like, I'll try it out and I'll see. I had my first position at Rice was a part-time instructor. I was just teaching. I was filling in on physiology. And then, I put in a full application for the position, but it wasn't like a dedicated sort of effort that I was like, this is my path. This is the way I'm going to go. It kind of just turned out that way. In terms of teaching, I feel like you have the ability to impact people in a way that is profound. Like sometimes it's just a small conversation here and there. And then you can also create these programs, right? So these amazing programs that are training students to do great things. And so you can operate on various scales. And at the same time, you're still learning and you're digging into data. It's a different type of data, but you're still doing all the things that research does as well. So that it's been fun for me.
All right, so let's move to a couple rapid fire questions and then we'll wrap for our conversation today. First, what is your favorite spot on the Rice campus?
My favorite spot. It would probably be Fondren.
Why? Why? What about Fondren?
I think I've always had a thing for libraries. That's just really kind of, that just says who I am, but I always feel the happiest when I'm in a library or surrounded by books. But I think Fondren's just beautiful. I actually visited Fondren when I was in because I'm from Houston, so I would go in high school as well. But yeah, I think Fondren's probably my favorite spot.
That's great. What's the best book that you've read recently, or a book you'd recommend?
Think Again by Adam Grant is a great book. I'm in the middle of two or three books right now, but that one I did finish actually, cover to cover. And that book is all about sort of challenging your assumptions, right? So challenging the way you're thinking. So when you're presented with the problem, a lot of times we just jump in, right? So that taking a step back and not approaching things in the conventional way we've been taught or our experiences have taught us, but just separating yourself from the biases. And I think that that's very powerful today, especially with like AI and everything else.
All right, and then last question. So when students apply to Rice, as I'm sure you know, they are presented with the box, which is a question on the application where they're asked to share an image of something that appeals to them or share something about themselves, their interests, what's meaningful to them. And so I'm curious, what would you put in that box?
I think, when I was younger, I may have I was a big space buff. So I think when I was younger, I really thought a lot about space and because I think that it fascinated me. I think now it's probably humanity. I would probably put a person because I'm genuinely curious about people and how they think and how they act and, how they suffer, how they feel things. And so I would put just another human being. I think that's what fascinates me the most.
Awesome. Great. Well, this has been a really interesting conversation. Thanks so much for sharing about your work, your teaching, all the things that you're doing at Rice. And really, it's been fun to learn more about this field and the things that you're focused on and interested in and the ways that you're supporting students at Rice every day. So thank you again for the time.
Oh, it's been so much fun, David. Thank you so much for having me. It's been great. I'm very lucky to be at Rice, and it's a fun day every day. I feel like the students make it worthwhile for me.
Great. Thanks so much.
Thank you.